A parabola is the set of all points in a plane such that, for any point P in the set, the distance to a fixed point, called the focus, is equal to the distance to a fixed line, called the directrix. Like circles, ellipses, and hyperbolas, parabolas are conic sections, that is, curves obtained by slicing a right circular cone with a plane. Specifically, we obtain a parabola when the plane is parallel to exactly one generatrix line of the lateral surface of the cone and intersects its base. The focus of a parabola is a fixed point in the plane around which the parabola is constructed. The closer the focus is to the vertex, the narrower the opening of the parabola. Conversely, the farther the focus is from the vertex, the wider the opening of the parabola. Parabolas have only one focus, unlike ellipses and hyperbolas, which have two foci, and unlike circles, which have no foci. The directrix of a parabola is a fixed line in the plane used to construct the parabola. It determines the shape and orientation of the parabola. Specifically, the closer the directrix is to the vertex, the narrower the opening of the parabola. Conversely, the farther the directrix is from the vertex, the wider the opening of the parabola. The directrix can determine the shape of the parabola because the distance from the vertex to the directrix is equal to the focal length, which is the distance from the vertex to the focus. What's more, if the directrix is horizontal, the parabola opens upwards or downwards, whereas if the directrix is vertical, the parabola opens to the right or to the left. Parabolas have only one directrix, unlike ellipses and hyperbolas, which have two directrices, and unlike circles, which have no directrices. The vertex of a parabola is the point on the parabola at which the parabola turns around. It lies halfway between the focus and the directrix. It is the point on the parabola closest to the focus and the directrix. Parabolas have only one vertex, unlike ellipses and hyperbolas, which have two vertices, and unlike circles, which have infinitely many vertices. The axis of symmetry of a parabola is a line that splits the parabola into two congruent halves called arms. It passes through the focus and the vertex and perpendicularly intersects the directrix. Parabolas have only one axis of symmetry, unlike ellipses and hyperbolas, which have two axes of symmetry, and unlike circles, which have infinitely many axes of symmetry. Lastly, the focal length is the distance between the vertex and the focus. It determines the shape of the parabola. Specifically, the shorter the focal length, the narrower the opening of the parabola. Conversely, the longer the focal length, the wider the opening of the parabola. A chord is a line segment whose endpoints lie on the parabola. Focal chords and the latus rectum of the parabola are special types of chords. A parabola can have infinitely many chords. A focal chord is a chord which passes through the focus. The latus rectum of the parabola is a special type of focal chord. A parabola can have infinitely many focal chords. The latus rectum of a parabola is a chord that passes through the focus, is parallel to the directrix, and perpendicularly intersects the axis of symmetry. It is a measure of the opening of the parabola. Specifically, the shorter the latus rectum, the narrower the opening of the parabola. Conversely, the longer the latus rectum, the wider the opening of the parabola. The length of the latus rectum is 4 times the focal length. Lastly, a secant line is a line that intersects the parabola at exactly 2 points. Secant lines always cross the parabola, unlike tangent lines, which only touch the parabola at 1 point. We can draw infinitely many secant lines that intersect a parabola. An external point is a point that lies outside the parabola. Given an external point, we can draw only two tangent lines to the parabola from it. A tangent line is a line that touches the parabola at exactly one point. Unlike secant lines, tangent lines never cross the parabola. We can draw infinitely many tangent lines to a parabola. However, from an external point, we can draw only two tangent lines to the parabola. A point of contact is a point at which the tangent line touches the parabola. The tangent line and the normal line intersect perpendicularly at the point of contact. A normal is a line perpendicular to the tangent line. Lastly, a chord of contact is a chord whose endpoints are 2 points of contact. When we draw two tangent lines to a parabola from an external point, these tangent lines touch the parabola at two distinct points. The line segment connecting these 2 points of contact is called the chord of contact. The axis of symmetry of a parabola is a line that splits the parabola into two congruent halves, called arms, which are mirror images of each other. The two arms start at the vertex and extend away from it in opposite directions infinitely, never meeting again after they separate at the vertex. Like, share, and leave a comment. Thank you for watching, and don't forget to subscribe to my YouTube channel.